Today we're going to talk about the AI's revolution and its impact on Elixir. I have a disclaimer. This is an AI conference and we're going to try to sneak a little bit of Elixir in. But we're not going to talk so much about the impact of AI on our careers, on the world. We're going to leave that for another time. We're going to talk about the AI's impact on Elixir. And in case you've never been to a Bruce Tate talk, there's going to be a metaphor. And since I am sharing the stage with the great Josh Price, he is also an accomplished photographer and adventure traveler, so we're going to use our journeys in places and national parks and World Heritage sites and we're going to pay special attention to the idea that these places are set aside for the benefit and enjoyment of the people. Much like Elixir and open source is set aside for the benefit and enjoyment of we the people. And that's really why we do what we do. That's why we contribute to open source and community and give conference talks. Here's how we're going to break it down. I'm going to talk about the old case for Elixir. Josh is going to talk about all the cool stuff, and then I'm going to close. But first, I want you to recognize that your case for Elixir depends on your personal journey. This is Bon Jesus, or as we would say in Mississippi or Tennessee, Bomb Jesus. So this is a cathedral grounds and stairways leading up to kind of this beautiful cathedral. And all the way up, there are these little shrines and fountains and places that you can stop and imagine and wonder and reflect and engage. And all the way up, people from around the world, from all walks of life, all religions and creeds, ages, races, will make their personal Camino. And that's the way it is with our Elixir journey. You see, Sasha's Elixir journey isn't my Elixir journey. And Laura's Elixir journey isn't Sasha's Elixir journey. My Elixir journey starts with a cup of Java. It's not the first language I encountered, but this is the first one I really remember because most of the languages that I encountered during my career were something that my boss told me to use, but Java was something that was a little bit different. This started to pop alongside the internet, and it was hard to see which one was growing faster some of the time. And as part of Java, we would go every year to the Marriott Moscone Center and Java One, and we would kind of share the community that was bigger than where any one of us worked. And you had all these small startups and all these big corporations, the Oracles and Suns and IBMs, in the midst of all these tiny startups that grew into these household names. But my early experience with Java was these very simple objects and themes. And the scary thing is that these things are called POJOs, plain ordinary Java objects. And that's a 4-letter acronym for the most basic thing in the language, right? And this was mind-blowing to me. And by the time that I left Java, it was a lot like the Vasa Museum. Has anybody ever been to this place in Stockholm? Every project manager on the planet should have to go to this place because they took this really simple boat and they started adding stuff to it. These 500 sculptures to symbolize the might and the majesty of all Sweden, and more on the front, and all these cannons and more cannons. And since there was a ship at the line from some other company or some other country that I can't remember, they wound up with 64 cannons on this boat, the mostest, the bestest, until it was too much. And they sailed this boat less than a mile off the coast, and it sank to the bottom. And that's my trip through Java. And then I went to the Ruby language, one sea-based metaphor to a shore-based metaphor about the sea. Ruby called out to me like a beacon, and I embraced it for its simplicity. And as a sales tool, we used to show this massive stack of books of all the things that you had to learn if you wanted to get into Java, the programming Java, the struts, the JSPs, the servlets, and then the enterprise Java beans that had entity beans and session beans and messaging beans and all these beans and the stack of books that were all bigger than 600 pages each. And then we showed that next to this small stack, this shiny stack of 2 books, Programming Ruby and Programming Ruby on Rails, and I was happy. And so this is the Japanese National Garden in Shimane. Beauty and harmony, and that's what Ruby was to me. All of this simplicity and a clean way to program. And I recognized that part of it was that I didn't have to do all the things that Java needed to do. I solved this problem over and over. I put this web interface in front of a big fat relational database. And this was the application that I built over and over and over, and I didn't need very much. And I started a company, well, renamed my Java company to a Ruby company, called it Rapid Red. And at Rapid Red, we started to recognize that even though you could get most of the way there with a relational database and a web UI, you couldn't get all the way there. So we started up with this concept called 3 blue chips. And a blue chip is the highest denomination in a lot of poker tables. And so we would say, customer, you could have these 3 metaphorical blue chips to buy a feature that's outside of the scope of Ruby on Rails. And the people that bought from us were really into this because 3 chips seemed like a lot of chips to add to an application, especially when you didn't have to pay for all that, the piles and piles of Java stuff. And it worked. And it looked a little bit fragile. And in fact, it was a little bit fragile. But it worked pretty well. And we did this over and over. But then the customers got wise, and they started negotiating for a few more chips, maybe. Or bigger chips, maybe. And eventually, if you kept adding chips to the pile, bad things would happen. You see, we were dealing with the wrong abstractions. We were trying to make the abstractions work for the business rather than making the abstractions work for the business, we were trying to make the business revolve around our 3 blue chips. And ultimately, Ruby was very good at optimizing developers, but only if it was able to make those developers behave and stay in the box. So over time, we were still using the 3 blue chips model when the processor designs changed and we needed to be building with more concurrency. And we knew this. And it became very clear to me that I was going to have to build in maybe 1 more blue chip, maybe even 2, before I even started every single project. The abstractions for concurrency didn't fit the abstractions for the Ruby language for me. And so I wrote this book out of fear, actually. And along the way, I found the Erlang language, and Joe Armstrong found me. And he took me under his wing. And he actually wrote the foreword to this book and opened a lot of doors for me. And eventually, I found myself giving the opening keynote in a language I knew nothing about at the Erlang user community in this venue. And we found this massive community. And one of the things that we would do is take an Erlang walk, and we would have conversations about all the things Erlang in Stockholm and that were happening in the world. And one of the places that we would always go was the most narrow alley in all of Stockholm. And that's kind of ironic if you're in a place that's embracing concurrency, right? It's like you have to line up and one after another would fit through this hallway. And I would look around in other places and in the language itself, and I would see in Stockholm and in Erlang all of this concurrency. And I would see all of these other things that I loved, like the distribution. And this was so simple and reliable, like these simple locks that used hand cranks to move all this shipping up and down in Canada. We had this really simple system that solved one of the most difficult problems in all of computer science. You want things to be self-healing and reliable. What do? Did you try turning it off and on again? Well, yes. And that's the way that OTP worked. But eventually, Erlang was not enough for the types of problems that I wanted to solve. It didn't quite fit what I was looking for. Maybe it was the lens that I was looking at after Ruby, but it didn't have the syntax and it didn't have the tooling that I was eventually looking for. So I waited, but I didn't have to wait very long. Jose also found this book, and it became one of the sparks that led to the Elixir language. I'll let you read this. This is the Tatra National Park in Poland. And this is what I felt like when I walked into Elixir. There was so much to like and very little that I didn't. I found all of the community that I loved about Java and Ruby. I found the foundational concepts like the POJOs, the structs, and the simple processes that I could deploy in a safe, reliable way, the little gen servers. And I found all the syntax and the tooling in Mix and the documentation. I found the concurrency and the distribution and the self-healing services. And I found enterprise, and it was robust, but it wasn't bloated. And then I came back to this idea of the blue chips. And when it was time to attack Elixir in anger, and I looked at these blue chips, I recognized that I could fit more in every application. There's a reason for that. Because the abstractions were better. Just as I walked towards this dry stacked, Richie, are you listening? The samurai castle wall. Yeah, that's the vision. Get it? So just as I walked towards this wall, the closer I got, the more that I could see the pieces fit together. The abstractions, like OTP, that allowed me to place processes into place. Like the web, I had plugs and contexts and lambdas and libraries, and even the event sourcing I could find in LiveView. Had all these open organizational tools around the web. I had protocols in the language itself for pluggable types. I had behaviors for pluggable modules that gave me the same inversion of control that I could get in other languages like JavaScript. So this is part of my first case for Elixir. Flexible abstractions that plug in many of the same things that you saw in the other languages. And in 2018, I founded Groxio Learning. And we started Gig City Elixir, that's a conference, and we started it to support a mentoring program that I had at the time to teach other people to use Elixir. It's called Elixir Chat. And Elixir Chat during COVID went underground, we went online, and it's there to this day. But earlier this year, before the apocalypse happened, you know, with the ChatGPT and all this stuff, this man who'd been coming to our Elixir chats year after year, Chris Miller, he said a couple of things that scared me to death. The first was that he had taken a job and he was writing code exclusively through LLMs. He was using nothing but JavaScript. The second was this. I haven't coded a Lambda in a year and a half. And I'm not going to lie, this was a dark moment for me. We're on this chat. One of the mentees that people looked up to had said, I don't have to write Lambdas. I don't have to write code anymore. And a lot of the people in this room have had a similar moment. Some of them might have been positive moments, some negatives, some moments might have happened in this room, or months ago, or even years ago. But here's how it felt for me. Many of you know that I took this trip as part of my escape from the weight of all that was happening. This was our COVID quarantine, right? We took a trip around the eastern United States. And there was this one moment that Maggie remembers very well, where we're tied up to this dock, and we don't even fit, right? Because this is made for these big old shrimp boats. And all the boats that had gathered around the area that were going to cross the Great Gulf of Mexico in safety, and we'd read all these stories about people encountering bad weather, they all left in a pack. And we were alone, and we were completely inexperienced, and we were completely unprepared.
Well, that got pretty dark, Bruce. I didn't mean to find myself in the middle of a Bruce Tate talk, but here I am. I've got a different take. He was worried about a fork in the road, and the left fork is the well-trodden path. It's programmers writing code the way we've always done. And as programmers, we craft systems with code and tests, and we make it great. And we try to get as good as we can, because it's a skill. And it's hard. And so is managing the complexity of the systems that we build with our code. But it does have one benefit, that it's deterministic. We can reliably predict when we pass an input to a function that we get the same output. If you remember your high school maths, teaching functional programming for me is really going back to middle school and reminding people that it's as simple as f of x. A pure function with the same input, always producing the same output, every single time. So this is my journey on the well-trodden path. And like Bruce mentioned, I love an adventure. I traveled through Africa for a year, and if you can see that four-wheel drive, that Land Rover Defender, that was what took me and a buddy of mine from London to Cape Town over the course of a year. And like Bruce, my Elixir journey took me through a decade of Java and J2EE with the singletons and the abstract factory beans and the EJBs and all the way back around to Pojos. And I nearly lost my way in that decade. And then I discovered Ruby, just like Bruce, just like Jose. And it was a productivity revelation. And those that were there will remember just how much of a step change that really was. And that was the next decade of my career. And I was so much more productive. It felt like magic, good magic, but was it? It seemed easy, but simplicity was just out of reach. And one day, I just remember this day very clearly, I was trying to find a bug and reason about some code, and I just couldn't reason about it at all. I didn't know where the code was coming from, and I looked in the console, and it was coming from everywhere, and I lost hope. And after some searching in the desert, just like Bruce and Jose, I discovered the solid and timeless foundations of the Beam, Erlang, and Elixir. And the Beam enabled enviable capabilities. It was surprisingly early, a hipster, if you will, with many solutions to problems that we're still trying to solve today as an industry. And Erlang, born in the 80s, nearly 40 years ago, did it before it was cool, and arguably did it better. We had distributed computing well before the internet. I was probably still using dial-up modems. We had clean and clear abstractions for mastering distributed computing before most of us even had or even knew what the internet was. We had concurrent processing before multi-core processors. And fun fact, dual-core processors only started appearing on commodity PCs in the mid to late 2000s. And so you could argue that was pretty early. And stacking upon the solid foundations of the beam is Erlang. With resilience, isolation, repeatability, before Docker and Kubernetes came along. We had health checks. We had auto restarts. We had process supervision, zero downtime upgrades, and built-in observability. It was amazing. We also had nano services before microservices. And we never really needed microservices because it solved the problem that Erlang and Elixir never really had, because it was a people problem when you had lots of people. And we don't need that many developers to deliver really, really powerful systems. And the modular monolith was always there, just chugging along, doing what it needed to do, simply and manageably. And OTP gave us the Gen server, which we've seen in Chris's talk and George's talk and other talks, that the future is looking very agentic. And the Gen server is the perfect agentic loop abstraction. It's so simple. You can fit it in a slide. And it just works. And it's a primitive that other ecosystems have to struggle to assemble lots and lots of infrastructure just to make something so simple work. And Elixir sits proudly atop all of these battle-tested technologies. What we have is a killer combination of functional programming, pragmatic functional programming, immutability, pattern matching, and types. And the types keep getting better. And they give us simple programs. And they eliminate entire classes of bugs. And simple programs are easy to reason about, not just for humans, but also for LLMs and whatever comes next. Elixir is a simple, low-ceremony language optimized for shipping. There's one way to do things, unlike Python, which tried to do this, but there's 17 ways. And there's no decision fatigue, like I found it when I spent a little bit of time in JavaScript land. But there's something missing. We still keep reinventing the wheel, and we don't have the level of reuse in our software that I think that I've always dreamt about as a software engineer most of my career. And the reason why is that this is your application. It's complex, and it keeps getting more complex by the year. Modern applications add ever more requirements, compliance, security, and frameworks and libraries only get you so far. What we want to build is the iceberg above the waterline. What we have to build is everything below it, and there's a lot. And we keep reinventing the wheel and duplicating things, resolving problems that our customers keep saying, you guys have, surely you've solved this before. And it's embarrassing when you have to say, yeah, not quite. And all of the innovation, all of the value, all of the differentiation for our customers' products and their core IP, which they really care about, is up here. But we spend most of our time down below in the commodity solve problem area with very low perceived value. And that's the reinventing of the wheel part. And any time spent down there, I would argue, is pretty wasteful. So how do we solve this? 3 years ago, we started using Ash. We discovered Ash. Zach built that, and he's been working with us for nearly over 3 years now. And it can help us focus on the important problems with our applications without reinventing the wheel. Let me take you through it. So this is our classic 3-tier architecture. Now, Ash lets you focus on what you want to build in the middle there. In Ash, you start with the domain or your business logic layer, whatever you want to call that, the application, the one in red, and you focus on declaring what you want to build in that core. And the top of the diagram is our UI, the user interface, and the green layer is our data, where we store the data or integrate with other systems. And the Ash core is written in a DSL, and we build domains and resources so that we do work in this layer, and then we generate the other layers as much as possible. Now, we still write UIs, and we could probably, with solid foundations, vibe program those those layers as well. That's kind of the disposable bit, in my view. We've talked to product teams where they're, founders and product owners and product teams and designers are skipping Figma and going straight to designing in vibe coding tools. Now they're prototypes, but they can inform rapid product iterations. And we're building all of that on top of Elixir's foundation of flexible abstractions with bigger building blocks and solid foundations. Now remember the fork in the road? There's another fork. And Bruce called this Easy Street, and it's kind of a good way to think about it. Easy Street's where you can build apps with ever larger prompts and hit the generate button. And now prompting and context management is the new skill. We're assembling ever larger prompts, but it's non-deterministic, and that is a skill, for sure. But there are dice rolls involved, and we need to be aware that the output, sometimes it's good, but it isn't always, and we need to take care. What we're seeing is a different kind of function, one that takes an increasingly large array of inputs and gives you a potential random array of outputs. And the skill is narrowing that probability distribution down as close as possible, as close to zero as possible. And it changes everything. But there are dangers. This is a little bit like a slot machine. On one side, there's a slot machine. The other, we've got vibe coding. Let's look at the differences. We buy tokens on both sides. We pull the lever on both sides. And there could be a jackpot or nothing. And humans are easily deluded, and there's a lot of cognitive biases at play here. And the gambler's fallacy, I think you probably know the type that can be deluded, hold on to that jackpot while pulling the handle 9 other times and not winning anything. So we need to be careful. So where did that last 4 hours go? On Easy Street, it's hard to tell really what is real and what is not. So we need to be careful. This is a study that was done, and it shows a proof that we can be easily deluded. What this data showed, and it's a study and it's worth taking a look at. You could argue about who the participants were and what the method was, but I think it just gives us a sense of our possible level of delusion. So what happened in this study was that every participant on average forecasted a 20% improvement in their productivity when they were allowed to use AI. And actually what was observed was a 20% reduction in productivity. Now they put that down to, well, you're generating code, but you're probably spending a lot of time elsewhere. So we need to be cognizant of where we're spending our time and where we're gaining. So it's not all bad, but on average, we can delude ourselves. And we are easily deluded. As humans, we're a meat-based assemblage of cognitive biases. This is one classic one, and you may know this, Dunning-Kruger. The effect or the bias is that people with limited competence in a domain, any domain, will overestimate their abilities. Now, this looks like a lot of other things. You may say that we're in an AI bubble. Can anyone spot where the bubble might be? The peak of Mount Stupid. Yeah, that's it. And so I believe Sam, you know Sam, he said bubble a few times the other week. And we may soon be in the valley of despair, but I think we'll be okay. Because eventually we rise out of the valley, and it's only short-lived. So what might the future look like? Jevons paradox was a counterintuitive observation where when James Watt in the 1860s invented a much more efficient steam engine, the British government expected coal demand to drop. Intuitive idea, but in fact, it soared. And the reason was because when we got more efficient engines, we got more demand for the things that they did. Similarly, in an AI age, when programming becomes easier, software becomes cheaper. And when software becomes cheaper, we get way more of it. Not all of it's going to be good. Vibe code produced by non-programmers is going to get messy, especially if they ship it to production. So let's not do that. And they're likely to speedrun every programming mistake ever made. This struck me as very real. I have blurred out some real faces. This is a new job title that just dropped. And so we're going to see some interesting things, and it's going to be a roller coaster like we saw on that Dunning-Kruger graph. Amara was a futurist who created a law to say that, on average, another cognitive bias, we tend to overestimate the effect of a technology in the short run, but underestimate it in the long run. So we may be in a bubble, and we've seen bubbles before, but they eventually get there. Dot-com booms, crypto, you name it. They start with over-enthusiasm and inflated expectations. There's a crash and a rise eventually. But the paths can merge again. I want to talk to you about a third possibility. The fork in the road is a false choice, and we can combine these roads. On one side, we have the deterministic path, the idea that we can reliably predict what's going to happen next. And on the other side, we've got non-determinism, where there are dice rolls involved. And we need to be aware that the output is sometimes good, but it isn't always. But what if we can have the best of both worlds? If we can be great at coding and prompting, good at the determinism, but also master the non-determinism, then we get the best of both worlds. And if we do one horizontal axis, we're vibe coding. And if we don't lean into AI and we just stick with traditional determinism, I think we get left behind at some point. You may have a little moment, but eventually that will happen. So, when we add AI on top of a more sound foundation, interesting possibilities emerge. With LLMs, you kind of get a random assemblage of ideas. And let's compare how with Ash you might deterministically generate repetitive boilerplate instead of using LLMs. We model our domain and we derive. Whereas we're prompting and getting shaky foundations. And what we want to do is use deterministic tools as much as possible, but on the edges we can use non-deterministic tools to build our solid foundations. But we don't want to run on those. I want to close with the fact that Elixir is uniquely prepared for the future. We definitely don't want to build on shaky foundations. We want to build on solid ones.
Did you get that? The new case for Elixir is the old case for Elixir. We have flexible abstractions with deterministic, larger building blocks. We can build on solid foundations, and LLMs can build on the same solid foundations, but with more determinism. And what we get out of this is, regardless of what you're typing into the terminal, we get excellent operational characteristics. So you don't have to worry about promoting the ideas of syntax and programming language. What we can do is promote outcomes. And so join me back in the Gulf of Mexico. Maggie and I are huddled in the hallway, making peace with death. And a boat pulls up. The name of the boat is Spiritus, but that's not important. What's important is that this man is on it, and he writes the blog that teaches great loopers to navigate the Gulf of Mexico. He writes this blog called Eddie's Weather Wag, meaning wild ass guess, right? So he stopped what he was doing just after he pulled into port. We helped him with his lines. And he said, listen, you're going to be okay. You're going to be okay. He said that the knowledge was the secret, that we didn't have to know how to navigate massive big waves or uncertainty in the Gulf of Mexico. What we needed to know how to do was wait until the weather was good, because we could control when we left. And there were some sites with great weather reports. And he showed me how to use them. And the way that he showed me was he said he pulled out his computer and he turned it around and said, Bruce, you type, where are you going to go to check? And I went to 3 sites, and all 3 of the sites were based on the same data. And he said, no, not those sites. Go to these. But eventually, I had down the idea of how to check what the weather report was for the following day. So he took the time, but then he left, just like everybody else. And we were okay with that. And the next morning, we woke up and it was glass. And we read Eddie's Weather Wag. And there was a message to us. Here's a message for all the loopers who haven't crossed yet. And we were the only one. Maybe you're still in town and you were teaching a class. He didn't say Elixir class, but everything else was pointing right to us. A surprising weather window looks like it's opening. You know what to do. And we did. We did know what to do. So we were alone in our crossing, but armed with the knowledge to solve the problem. We knew that we didn't have to know how to navigate rough weather. What we needed to do was wait until it was time to go. But armed with the knowledge, we lived, right? And the key to this process is to learn. And I have a couple of final parting thoughts for you. The tools are changing quickly, but you're going to be okay. You're going to be okay. In fact, you're going to thrive. Like Chris said in the opening keynote this morning, Elixir is ideally positioned for this moment in history, this moment in time. You are going to thrive. Enjoy your journey and cherish community. Lean on solid foundations and embrace outcomes and go build something great. Thank you.